period.
Sorry, I push record.
I was saying, does it mean you have to put your name many times?
No, just once. Just at the top of the test, you put your signature, and that's it. Not
Yeah,
each question.
because when I saw the retake, is it a timed test or I'm so
Okay,
tired.
so Michael, can we talk about this after class during office hours?
Or during the
All right.
break?
Let's do that because, or during the break, because I think I answered all these questions already, and it's just kind of taking time away from the class. So I can answer during the break if you have more questions about the makeup test, but it's available there. And if you guys need clarification, I can answer during office hours or during the break. All right. So yeah, this is the plan for today. So yeah, homework is due. If you had questions about deadline, homework is due by midnight. Okay, so that's the due dates for most things that you submit in Canvas. So midnight is the due date. Okay. All right. There's also a question. Sorry.
For that functions homework, what do we have to submit on Canvas, and then what do we just keep on the Google Doc?
So the classwork is in the Google Doc. So the classwork is the stuff that we're doing during the class time. So that one doesn't need any submission. It's just you do the work on there and I see it. But the homework, okay, let me go to Canvas. Oops. Sorry. Okay. All right. Okay, so the homework is this. Okay, so functions 1 homework is in these files right here. Okay, so I have it as a PDF and also as a doc file. So there's 2 versions of it. They're identical. And you can open up the file and you can do all the work on paper, take a picture, and then hit the submit button and upload the files in Canvas. Or you can open the doc file and type your work in there, and again, save the file and submit it in Canvas. So that's how the homework is submitted. All right, any questions with that one? All right. There's a question that says, how do you view what you got on the test? Okay, so I think for most of you, you're able to see the feedback. If you're having trouble seeing the feedback, again, if we can sort of meet during office hours, I'm happy to do that. But I can't show your stuff to other people, so we need to sort of meet one-on-one. All right, so what you need to do to view your test feedback is go to your grades. Right, and then find the test. So let's say you have, I don't think I have anything. Oh yeah, I haven't submitted an assignment on the test too. But let's say this is your test, okay? So you see the summer right here. You can click on the name of the test. Sometimes you might have a little comment on here. It kind of depends how you submitted your test. If you submitted in Canvas, then the best thing to do is click on here. If you had problems submitted in Canvas and you emailed it to me, then I probably attached a file here, okay? So if you click on the test, then you will see your submission. You need to go to feedback. So if you go to view feedback, then it shows you a copy of the test that's been marked by me. And so the feedback will have all your sort of check marks and what you got incorrect, okay? Again, if you didn't submit in Canvas and you emailed it to me, then I don't think the feedback is there. I think that you need to click to the comment box there, and then I attach a file with your graded test. All right. If you can't find it, let me know, and outside of class time, and I can show you how to find it. All right. Any other questions?
Yeah, I got a question, Professor. Somebody might have already asked, but where do we submit the classwork from yesterday, functions 1 from yesterday?
The classwork, it's automatically submitted. So anything that you do in Google Docs, it's already submitted because I have access to it and I can see what you've done and I can grade it.
Okay, thank you.
Right? It's the homework is not automatically submitted. So the homework you have to do on paper and upload the files to Canvas because the homework is individual. So I don't have like an individual Google Doc for each of you unless you do it in Google Docs and share me. But I think it's better if you just do it in Canvas. So the only thing you're submitted in Canvas is your homeworks or any quizzes or tests that you take. All the other classwork stuff, it's already submitted.
Okay.
Okay, cool. All right, any other questions? All right, so let's look at what we were talking about yesterday. All right, so we are in the function. And so I think we went through this. And I was just going to review what we're talking about. All right, so we're talking about function notation. What is a function, like the vertical line test. And we'll kind of talk about domain and range a little bit more. But we kind of stop with this example where we're evaluating functions either by plugging in or by reading a graph, okay? So now it's kind of time for you to explore and practice. So we're going to spend some time working on the functions 2 classwork. All right, so let me open that up. This is the homework. I have way too many files open, I know. Okay, let's see. So functions 2 classwork. So you should have a link to that I sent a couple of days ago, I think. Right.
Professor, are those slides that you're showing, are those on Canvas?
They are on Canvas, yeah.
Okay.
All right. Here, kitty cat.
I'm sorry.
No, it's okay. It's cute. My internet is a bit slow.
I'm sorry.
Me too. It's just taking a little while to load. Okay, there's a question. If you didn't finish the function 1 classwork yesterday, you need to finish it. Okay, it's basically the same as any activities that we do in class. We start things in class time, but if you don't finish it, then you need to make sure that you finish it outside class time. Let's see, functions 2 classwork. And when I graded, I sort of grade by completion. So if you I can't seem to be opening the correct file. Okay, let me search for it. Functions 2. Functions 2 classwork. Okay, that's what it looks like. Okay, so yeah, go ahead and log into your group for Functions 2 classwork. So if you can't find the link in your email, let me know and I can send you one. But it should be your email. I think I send it Sunday night. I'm gonna close a few files because maybe that's why my computer is acting a bit slow. Okay, I'm gonna let you guys have a couple of minutes to find the link there, or let me know if you don't have it. Okay. There we go. Function 2 classwork. Perfect. STEM groups. So click on the link and I'll send it to you. If you don't have it, just let me know through chat. Oh, that's why my computer is slow. Saving all those Zoom sessions is working it really hard. Come on, open up. There we go. Okay, so let me give you an overview of what we're doing to start with. Okay, so the first bit in the classwork is an investigation. So we're trying to identify things that are functions and are not functions. Okay, so it says below are 9 representation of relations. And we want to know if these relations are functions or not. Okay, so the first 3, A, B, C, are given by graphs. Right? So,
Professor,
graphs,
for our group, those graphs aren't there.
can you refresh the page? I think it took a little, like a few seconds for them to appear for me.
Mine is loading.
Yeah, I think it might just take a couple of minutes for them to load up.
Oh, okay.
Also, Professor,
I
use
was like, what is she looking?
function 3 instead of function 2 today, because I don't have function 2.
The function 2 was sent Sunday night. Okay. So
Yeah, then I don't have it in my email.
all right, I will send you the link. Let me see which group you're in. All right. You're in group 2. Okay. Let me open up group 2 and I'll send you the link via chat. Functions 2. Group 2. That's functions 1. Sure. All right, anybody else having trouble accessing the file?
Sorry, which file?
Thank you.
Functions 2 classwork.
Oh, I got it.
You got it? Perfect. All right, so if we look at the pictures ABC, okay, of the graphs, how can you tell whether they're functions or not? So
You use the vertical line test?
yeah, we use the vertical line test. Okay, so how about A? Is A a function?
Yes.
Yes.
Yeah, right, because basically it's a function if any vertical line you draw is going to hit the graph at most once. So it doesn't like double up on itself, like if you draw a vertical line. So
are we typing in those answers next to the graph?
I don't think that you can because it's like a big picture. So so maybe below all the questions. Like when it says step 1, identify each relation that is a function. For each relation that is a function, explain why not. So in that area right there, say A is a function because it passes the vertical line test. Okay, so I think that area, and I can spell because, there we go. In that area in step 1 is where you put your answers, because I think the sort of that area with where the graphs are, it's like a picture file and you can't really type on top of it. All right, how about B? Is that a function or not?
No.
No. All right, because that one I can draw a vertical line and it's going to pass more than once. Okay, so that's the definition of a mathematical function, is that for each value of x, it is only a unique value of y that's associated with it. Okay. How about C? C is not like a continuous curve, it's like a bunch of points. All right, so that the vertical line test would work too. So it's like if I draw a vertical line, is there any place that is going to hit at more than one point?
Wouldn't it have to go through one of the points to pass?
Yeah, so like here, I can draw a line and it goes through one point, but it's not gonna, it doesn't go through more than one point, okay? So same for like, if you look at each single point there, it's only passing, like a vertical line only passes through at most one point. It's never gonna pass through more than one point. So there's no points that are like on exactly on top of each other.
Mm-hmm.
Okay, so that makes it a function. All right, now let's look at D, E, and F. Okay, so these are sort of their charts. Kind of in the first column gives you X value, and in the second column gives you Y value. All right, so again, we need to identify whether these are functions or not. Okay, so again, the definition of a function is that for a particular value of x can only have one value, a unique value of y associated with it. So if you have more than one y value for one value of x, then it's not a function. Okay. All right, so let's look at D. So does this represent a function?
Not a function.
Okay, so let's see. So x is 1 goes to y is 1. Okay, so x is 1, there's only one y value that belongs to it. So far, so good. How about x is 2?
It is a function.
Right, it is a function because x is 2 only goes to y is 3. So it goes to a unique value of y. X is 3 goes to y is 4. So 3 goes to a unique value of y. And x is 4 goes only to y is 2. So again, only to a unique value of y. So that's a function because it fulfills that rule, all right? Which one of these is not a function, like D, E, and F? Which one breaks that rule?
E.
E breaks the rule? Does it?
No, F, because F has 2. F has the 1 on 1
right,
and
F
on the
breaks
3.
the rule, right? So E is a function because it's like, again, a function is like for a particular value of y, it can only go to, for a particular value of x, it can only go to one value of y, it can't go to more. So 1 only goes to 2, so that's fine. 2 goes to 2, that's fine. 3 goes to 2, that's fine. 4 goes to 2. So for each value of x, it's only paired up with one value of y. So E is a function. But F is not, because if I look at x as 1, 1 is paired up with 1 for y, but it's also paired up with 3 for y. So this one value of x goes to 2 values of y. So that makes it not a function. Okay. All right, any questions with that? All right. So yeah, if you kind of look at it in terms of coordinate points. Okay, so for D, for example, if I write x and y, I have 1, 1, and 2, 3, and 3, 4, and 4, 2. Okay, so you can see that like each x value goes to its own y value. It doesn't go to more than 1. But for F, if I look at the F right here, I have 1 goes with 1, but also 1 goes with 3. And 2 doesn't go with anything. 3 goes with 2, and 3 goes with 4. Okay, so this is not a function because the value of x is 1 goes to 2 separate y values. Right? If you're going to graph these points, then you could draw a vertical line through them. All right. Okay, let's look at G, H, and I. So let me get rid of these. Okay. So G says the independent variable is the x, and the dependent variable is the y. Okay, so that's what they stand for. So independent is the x value, and dependent is the y value. All right, so this is x and y. All right, so for G says the independent variable is the age of each student in this class. So x is the age, and the y is the height. Okay, is this a function? Okay, so basically, in other words, does an age, a particular age, go to only one height?
No.
Right, so if you are 20, can you only be 5'4"? Or
No.
can you be 6'2"? Or, all right, what do you think? Is this a function or not?
No.
No? I got one answer. Anybody agree, disagree?
I think it's no.
Agree with no, right? Because like if you look at different ages in the class, like so somebody who's, I forget what I say, 20, you have a student that's 20, they could be 5'4", but somebody else who's age of 20, they could be 6'2". So that particular value of X could go to more than one height. Okay, so that's a no.
Well, why is it a no in G?
Because for a particular age, like a person whose age of 20 could be 5'4", but another person whose age of 20 could be 6'2". So one particular value of X can have more than one value of Y associated with it. So that's a no, that's not a function. All right, how about I let you guys spend a couple of minutes on H and I. So this decide whether those are functions or not.
I like when she gives us the answers.
Oh.
So how much learning do you do when I give you the answers?
Oh.
I'm not there on the test when I get to give you the answer. Am I? All right, how about those H and I? Okay, so H. So your X is?
H is the function, I think.
Yeah, so X is automobiles and Y are license plates. All right, so the question is, does each individual automobile have a unique license plate, or can I have more than one license plate for each unique automobile? Right? So, and this is, yes, this is a function because each unique car has its own license plate. It can't have more than two, unless you're doing something shady, right? But let's say you're not doing that, okay? Okay, and I? So
I put no because of daylight saving times.
Oh, so the day of the year and the time of the sunset?
Because doesn't it go down like super early in winter, and then in summer it's daylight till like 7 o'clock?
Right. So the day of the year means the day of the year is like April 7, okay? Or the day of the year could be April 10, or it could be December 24th, okay? And the time of the sunset. So on April 7, can I have different times where the sun sets?
I mean, if anything, maybe by the minutes, but hour-wise is probably still about average, right?
Yes,
Yeah,
because of time.
so yeah, you're thinking from year to year. But how about if I'm thinking at a different location? Like, is the sunset the same time in San Diego as it is in Chicago?
No.
Right. So again, geographically, even though it approximately might be happening at the same time, it probably not to the minute. Okay. That one's a kind of wishy-washy one. You can kind of go, yeah, maybe it's the same time because it's sort of happening in the evening. But if you kind of try to be more precise and if you sort of look at different locations, then it could be different. Okay. So So that same day could have different times when you sunset if you're in different location of the world. Okay.
So if you're going by
is
different
yes.
locations, would it be no?
Yeah, if you're going by different locations, it's a no, because even if you are in the same time zone, like we might be the same time zone in a certain part in California, but the sunset will be slightly different minute because geographically you're in a different place. So somebody who is more inland could see the sunset go down at a different time than if you're next to the beach. Okay, so it's kind of you could sort of argue it both ways, I think, whether it's the same time or not, but it's sort of that one is not set in stone. All right.
Oh, is it did we decide, is that a yes or a no?
It could be either, depending how you argue it. Okay, so that one you kind of have to be a lawyer, and sort of if you sort of give the answer yes or no, just give an argument that kind of fits with your decision. Okay. All right, so let's look at step 2 now. So now for functions in parts A through F, find the y value when x is 2. And then find the x value or values when y is 3. Write each answer in function notation. Okay, so A through F. All right, so just these top 6 ones. Okay, so I won't go through every one of them, but I'll show you, I'll go through a couple of examples. Okay, so let's look at graph C. So what is the y value when x is 2? Okay. So when x is 2 on this graph, what is the y value?
1.
So x is 2 is right here. Does it have a y value?
No, it doesn't.
It doesn't have a y value because there's no dots anywhere on the graph of x is 2. So for part C, there is no y value for x is 2. Okay, so that's an answer. All right, and it also asked, what are the x values when y equals to 3? All right, so if I look at the graph, y equals 3 is here. Okay, so I see a couple of dots when y equals 3. Okay, so that happens in a couple of places. So I have an x of 1, and I have an x of 3. Okay, so when it says to write it in function notation, that means, so for graph C right here, you could say the function C when x equals 2 does not exist, right? And the function when x is 1 gives me a y is 3, and the function when x is 3 gives me y is 3. Okay, so that's what it means, write it in function notation, using the letter of the subpart as the function name. Okay, so that's the answer for part C. Okay.
Oh, but in my group, they wrote it as A to F. They did it in my group.
They wrote it as F?
No, A to F as the steps.
Okay.
Michael, I just put it there so that we could write our answers next to it.
There you go.
It makes more sense.
Yeah.
Perfect. All right, let's do this with how about with E? Okay.
Oh, good idea.
All right, so again, we're looking for E. We want to know what the function value is when x is 2. Okay, so the function E evaluated at x is 2. So what is the y value when x is 2?
2.
2. Okay. And then it says find the x value when y is 3. Okay, so what is the x value for this function and when y equals to 3? Are there any x values that are
No.
connected to? No, so
No.
this does not exist. Okay. All right. Okay, so now the rest of the file has a few problems. They're very similar to the homework when you do them. So some of them are, do the graphs represent functions or not? And you explain, so they're graphs, so you can say it passes the vertical line test or not. And number 2, you're evaluating, find each of the indicated function values. So you're given a bunch of values in function notation, and that basically tells you to plug stuff in. Right? Number 3, you're looking at function values using a graph. Right? And then some of these are more wordy problems. So let's work on 1, 2, and 3. So I'm going to let the groups work a little bit independently. And then I'll check in with the groups, see how they're doing just by looking at the files, and I'll go over some of the parts, okay? But I'll give you guys about 5 minutes to work on problems 1, 2, and 3.
I just don't remember. Did you say for B because it has various? So is it 2 for 1? It doesn't make sense. It doesn't work.
For which problem?
You were just on my group for 8B.
Is it for this problem here? Number 1?
Yes.
So you're trying to figure out if part A is a function or not?
No, on B.
On B. Okay, so yeah, if you draw vertical lines, if it can hit more than once, then it's not a function.
Okay, that's what I thought. Thank you.
You can just say it doesn't pass the vertical line test. That's fine. Or say that for each x value, you can get more than one y value. That's okay too.
Hey, Professor, I have a question.
Mm-hmm.
So for function notation, I'm kind of confused on how to write it.
Is this for like
We're in a group. I'm in group 5 if you need to look at it.
okay. Group 5. That's not it. That's not it. There we go. Are you working on step 2?
Yes.
You looks like you're
Yeah, so for D, where it says D is a function, so there's 2 parts to the function notation, right? Like we have to do find the y value when x equals 2.
Yeah.
And so did I do the function notation right for that first part for D? I put D parentheses 2 equals 3.
Right. So D. So when x is 2, y is 3. Okay. So let's see. Let me look at the picture. Yeah. So D of 2 is 3.
Okay.
That's correct.
And then so for that second portion though, for the same question,
yeah,
portion of D at the bottom, it says find the x values when y equals 3.
Yeah.
So for this one, do I do D parentheses 3 because I want the y value first equals 2?
No, so inside the parentheses is always the x value.
Okay.
And then outside the equal sign is the y value. So this would be exactly the same answer.
Okay.
Yeah. So
we
have D of 2 is 3 for both parts.
Okay.
Yeah, the function notation is like, in the inner part, the inside is the x values and equals y, equals the y value.
Professor, I have a question on the same one. I'm working on B, and so there are like 2 points that match up. So am I writing all of those?
Yeah.
Okay.
So yeah, if you have x is 2, you have these here. So
okay.
B of 2 equals 2. And B of 2 equals 4.
Okay. So then for the other part of that question, I'm doing it in that exact same format?
Yeah. So when y is 3, you also have 2 of them, right?
You're
going to have B at 1 equals 3 and B at 4 equals 3. Okay, so yeah, the x value goes in the parentheses, the y value goes after the equal sign. Okay?
Okay.
All right, let's look at, can I help on number 2? Cool. All right, so yeah, let's look at, so number 2. This is a good place for me to jump in a little bit. I was wondering if you guys were going to ask me about that one. All right, so it says find each of the indicated function values. Okay. So it says I have f of x equals negative square root of 4x plus 1. Okay. So this is the function. So this is an equation form for the function. We've seen functions in different forms like graphs and tables and words. This is equation form. So when it says find f at negative 1 over 4, basically it's asking you plug this value for x in the equation. Okay, so you're going to have negative square root 4 times negative 1 over 4 plus 1. Okay, and then we're going to simplify that. It's going to be 4 times negative 4 is negative 1. And then you get negative square root of 0. And you're just going to get negative 0, which is 0. Okay, so this is finding this. All right, so for all of these, basically, you need to plug in. So f of 0 means you're going to take 0 and plug it into the equation for x and simplify it. And you're going to take that 0.75 and you're going to, so all they're different parts. Okay, so you need to plug in each of those x values to figure out. So this was 0 and you figure out the value for each. Okay. All right, so you can have a break, stretch your legs. we'll sort of be back in session at 2. But I'll be here, so if you have questions as you're working, I'm happy to answer them.
I was still talking about this.
Professor,
Yeah.
I have a question with number 3.
Okay.
So I know how we get to, or we use 3 equals x or whatever,
Mm-hmm.
and then we go up the line till we hit the line, right?
Yeah.
So I got 6. Negative
1,
3
2,
is nothing.
3, 6 or 7.
Okay, so 7.
Yeah, let's do 7.
And then what do I do about -3 if there's nothing?
Oh, you can see it at -3. So maybe we need to figure out, oh, and f at 10, that's not very useful either because you can't see in the graph. So maybe we need to find the equation of that line.
And the slope.
Yeah, so find, I know the y-intercept is -5, right?
Yeah.
And the slope, let's find the slope between these points. If I go up 4 units and 1 unit across, the slope is going to be 4. So what's the equation of that line?
I forgot.
Y equals mx plus b,
Oh yeah.
right? So y is going to equal 4x minus 5. Okay, so this is your function. So even though you're not seeing the whole function and you're not seeing like the points that you need, once you find the equation of it, then you can plug in the x values.
Oh, so basically 3 is equal to 4x times -3 minus 5. So just plug in the f of x.
No, you're plugging in what you're plugging in when you have the function notation. What's in parentheses, it's your x value. So f at
Yeah, so you'll plug that
means,
into the equation, right?
yeah, it means x is 3, and you're going to plug x is 3 in here. So you're going to get 4 times 3 minus 5. So that gives you 12 minus 5, which is 7, which is what we're guessing from the graph, right? And here,
Yes.
you're plugging in x equals -3, right? So plugging in x is -3 there, so -17.
Oh, so you wouldn't put it the 3 or -3 where f of x is at. You
No,
would just plug into
you put it
the
into,
x
yeah, you put it
after
into
the equal sign.
x. Yeah, so whatever's in parentheses here, you plug it into the x.
Okay.
All right.
So are we supposed to write out for the rest of these, we want it in y equals mx plus b form?
Well, this is y equals mx plus b form because it's a straight
Positive,
line.
so, yeah.
Okay, so from the graph, because it's a straight line, you can figure out what the equation is. Okay, so this one, we kind of needed to know the equation because from the graph, we can't read x is -3. It's like if you look at the graph at x is -3, we don't have the graph that shows us what the point is. Or in part B, it's going, what is f at 10? And I don't have x is 10 on the graph, and I don't have the y value. So because I can't read it, you want to find the equation to help you figure out those values.
Okay. So we're still using 4 and -5 for all of these.
Yeah, because once you find the equation of the line using the picture, then that line extends forever. And that's the equation of f of x, right? So you're using 4x minus 5 to answer all the parts.
Okay.
So for B, I would plug in 10 where x is at. So 4 times 10 minus 5.
Yeah. So the 10 in here, right, tells you x is 10, and you're going to plug it in for x here. So you get 40 minus 5 gives you 35.
Yeah. Okay.
And then you end up with this. Okay.
Okay.
And now you have to do it again, right? Because it's f of 10.
Oh yeah, I see.
Again.
Okay.
So now your x becomes 35, and you plug it back in.
4 times 35 minus 5.
Exactly. So this is like, we'll this is a preview of what composite functions. We're going to get to composite functions in a couple of seconds.
Okay. And what does it mean when it's saying x, when f of x is equal to -3?
So this is asking you to find the value of x when f of x equals -3. So this is when you're going to take your function and set it equal to -3.
Oh, okay.
And then you got to solve for x. You got to
So add 5 and then
add
divide
5
by
and then divide
4.
by 4. Exactly.
Okay, perfect. Thank you.
Mm-hmm. All right, so we're back up from break. So let me actually go over, let's look at number 3 in more detail for everybody. Right. So so let's look at what this says. So it says use the graph to the right to find each of the following. So part A says find f at 3 plus f at -3. Okay, so if I go to my graph, I can find x is 3. It's right here. And if I look up, I can say, well, yeah, y is going to be 7. So from there, I can say, yeah, that's 7. But then I need to figure out f at -3. Okay, so if I go to -3 right here, and if I look down, I don't have a graph there. So I can't really figure out the point from the graph, right? So the graph is it's not totally useful because it doesn't give me the information that I need here, okay? So it would be more useful if I had an equation to plug in, just like in part 2, I had equations that I could plug the numbers in. So I noticed that this is a straight line. And I know how to find the equation of a straight line because we've done that a few times, right? So we have y equals mx plus b, right? Okay, so let's build an equation from that graph. So what is the b value? So if I look at the graph, the b is the y-intercept, right? So I look here and I see that it's -5. So that's my b value. Okay. And x has to stay here because it's an equation. I have to figure out the slope. Okay, so I need to figure out the slope of this line. So slope, you want to figure out by picking 2 points that are on grids. Okay, so this is a good point. This is also a good point. So I need the rise over the run. So I can see that I'm going 4 units up and 1 to the right. So it's a positive slope. So my slope is 4/1. All right. So I can say that my function is 4x minus 5. Okay, so basically the function f of x gives you the y value, right? So from the graph, I found the equation. And this is more useful for answering those questions because I can plug values of x in and I don't have to read them from the graph. Okay, because a lot of the things that are asking, they're missing from the graph because the graph is not big enough, right? So let's look at this. Okay, so now f at 3 means that you're going to, it means that x is 3. So this 3 inside the parentheses means x is 3, and you're going to plug it into the equation. So if I plug in 3 in the equation, I get 4 times 3 minus 5, and 12 minus 5 gives me 7. All right, so that's the answer for this part. But it's asking me to add it to f at -3. So I need to figure out what the function is when x is -3. So I plug in -3 in here. So 4 times -3 minus 5. -12 minus 5 is -17. Okay, so now I combine them. So 7 plus -17 gives me -10, like this. All right, any questions with that one? All right, so let's look at B. So B says find f of 10. All right, so it's kind of like you're doing it twice. So the only thing I know right now is this 10. So the inside part is the x value. Okay, so this tells me x is 10, and f of 10 means that you're going to plug into the equation. Okay, so I'm going to have 4 times 10 minus 5, which gives me 35. Okay, so that answer replaces that inside f of 10. Okay, but we have to basically keep going until we figure out, evaluate everything. So now this 35 becomes my x. So now x is 35, and it goes back in here. So this is 4 times 35 minus 5. 140 minus 5 is 135. So this is the answer, 135. Okay. Now for C and D, you're kind of going the other way. It's like find the value of x when f of x is negative 3. So basically that says f of x is negative 3. That means for x minus 5, the formula equals to negative 3. And we need to find the value of x. So we need to solve for this. So we add 5 to both sides. We get 4x equals 2. Divide by 4. So x is going to be equal to 1/2. Okay. All right. And then for D, similar thing says find x when f at x minus 3 equals 35. And we're going to start with, so basically the x gets replaced by what's inside the parentheses. So 4 times x minus 35 minus 5 equals 35. So whatever is inside the parentheses gets plugged into the formula for x. And because the whole thing equals 35, you set it equal to 35. And then you solve this equation. We have 4x minus 12 minus 5 is 35. 4x minus 17 is 35. 4x equals 52 divided by 4, so x equals 13, I guess. All right. Okay, any questions on number 3? No. Okay, so there's a question in the chat. Can I go over the function notation in step 2 again? The step 2 as in, I'm assuming is this step 2 part. Okay, so function notation. Right, so let me pick one of them. So let's say that I'm going to look at let's look at number E. Right? So it's saying that we want to figure out what the function, what the y value is when x is 2. Okay. So I see when x is 2, y is 2. So to write out in function notation, we say, I'm going to call my function e because this is part e. The x value goes in the parentheses and the y value goes outside, equals. So e of 2 equals 2. So the function when x equals 2, the y value is equals to 2. So that's function notation. All right, and it's also saying find the x values when y equals to 3. All right, so basically saying, what should I put in parentheses here so I get y equals 3? All right, and you see that nothing could go in there because there's no arrows going to 3. this doesn't actually exist. There are no x value that take me to y equals 3, okay? All right. Okay, any questions on number 2 or number 3 as you guys are working through it before I move on to some of the other problems? All right, so let's look at number 4. So Miguel works at an appliance store. He gets paid $5.25 an hour and works 8 hours a day. I think I got these problems from a book that was published 20 years ago. I hope nobody still gets paid $5 an hour. That's like, should be outlawed.
People in the South do.
They still do. Oh my God, I remember when I was in college, I worked at a grocery store and I got paid $3.25 an hour.
It's mainly servers. They
Yeah.
live tips.
Oh, because they get tips on top. But still, that's just like, it should be outlawed. Anyway, so in addition, he earns a 3% commission on all the items he sells. Oh, he gets commission too. It's still bad though. So X represents the total dollar value of the appliances that Miguel sells, and let the function M represents his daily earnings as a function of X, which function describes how much Miguel earns in a day. Okay, so we've looked at problems like this in the past with, I think we're doing which one is the best job, those kind of problems that you kind of looked at people's salaries based on the base rate and also the commission rate. So let's look at, so M represents his salary based on X, which is how much he is selling of appliances, okay? So which function do you guys think it is? A, B, C, or D? So look at them kind of, you want to look for a flat rate and like a percent based on how much he's selling. Let's see, M, how much he earns in a day. Okay, so how much does he earn in a day even if he doesn't sell anything?
$42.
$42, because that would be, right, if I take his hourly pay and I multiply by how many hours he's working, right, that gives me $42. So those $42 he's earning just by showing up. Okay, so that's like the flat rate. Okay, but then to that, we need to add what he's making on commission. So it says 3% commission on the stuff that he sells. Okay, so how do I write 3%?
0.03.
0.03, and then that has to go with X because it's going to be 3% of something, 3% of what he's selling. Right, so his daily salary is made out of that $42 that he's sort of $5.25 an hour for 8 hours, and then the 0.03X is variable. It's based on how much he's selling every day. Okay. All right, any questions with that one? Cool. All right, so this is kind of revisiting some of the stuff that we were sort of looking at before, but in function notation. Okay, so you've noticed that we're sort of seeing things that we've sort of seen before, kind of just rephrasing it as functions, and also some things that are new. All right. Let's look at Okay, I'm gonna ask you guys to work on 5. Okay, so 5 is similar to 4. You want to write a function that describes each situation. So you drive on an interstate at 65 miles an hour. You don't need to stop or alter your speed. So maybe you can write a function that describes that situation. You have to kind of decide on what variables to use. And part B, you rent a small moving van to move your belongings. The rental company charges $45 a day plus 22 cents a mile to rent the van.
Can you scroll back up to the previous problems you just did really fast, please? There you go. Thank you.
Mm-hmm. All right, so let's look at 5. Okay, so for part A, what could my variable be in here? So I'm driving a certain speed, and that's a constant speed, 65 miles per hour. I'm not stopping, I'm just going. So So what function, what am I interested in? Oh, what variables could I have in this problem? Any suggestions?
Would be distance and time.
Yeah, the distance and time. So basically I'm interested in d is the distance and t is the time. And you just said that distance equals the speed times the time. Okay, so I could have that the distance is a function of time, and using this formula that we know is going to be the speed, which is 65 miles an hour times t. Okay, so that's a good function that I can write. So distance depends on the speed and depends on the time that I'm going, but I know I'm going 65 miles an hour constantly. So that's a function that describes how much distance I covered in a certain amount of time. All right.
We just use f of x to make it easier.
Yes, you can absolutely use f of x. Oh, f of x equals 65x. Yes, I can use x and f instead of all the other ones. All right. How about B? So you rent a moving truck, rental company charges you $45 a day and 22 cents a mile. So what kind of function can I write here? Let's use f of x. F of x equals
Would it be 45 plus 0.22x?
yeah, that would work. So basically x is how many miles? And the f of x, the function would represent the charge, how much you're going to pay to the rental company. All right, cool. All right, let me, I'm gonna open up a different file. I think I've been in group one forever. I'm monopolizing group one. So let's open up another one. Oh. Okay, let's look at 6. Okay, so we've mentioned domain and range a little bit. Let's look at, it says identify the domain and range of the function f on the graph it right. Okay, so the domain represents what x values are used, and so the domain is the x values and the range is the y values. Okay, so if I look at this function right here, now if it has arrows at the end, it means that it kind of keeps going forever. So when you write the domain and the range, you have to sort of go to infinity sometimes. But if it stops, those are basically the stopping points, okay? So if I'm looking at a domain, I'm gonna write it like an interval notation because it's a range of values that are happening. So basically the domain of this function is like what x values were used to draw this graph. All right, so what do you think? Where did I start? What value of x am I starting with?
-6.
-6. So -6 is the first x value where I have a graph. And what is the last x value that it's used for?
4.
No, I'm going past 4, right? So 4, I get 0, but I'm actually going to 5, right? Because at x is 5, I still have a graph down here. Right?
Oh.
So basically you need to go from one end to the graph to the other end of the graph, but you're reading the x values. So here at this end, the x value is -6, and at the other end of the graph, the x value is 5.
We're only reading the x values?
For the domain. So basically that's what the domain means. It's like, what x values have I used to generate this graph? So I used all the x values from -6 to 5. Right? Now the range is the y values. So the range, I want to kind of figure out what y values were generated when I used the x value. So we're going to look at the graph and identify what's the lowest y value where a graph was drawn and what's the highest y value where a graph was drawn. So what is the lowest y value?
-2.
0? Oh.
-2, right? At -2, right? At -2, I have a graph, right? And all throughout -2, if I look across, I see a graph. So what's the highest y value that has a graph?
4?
4, yes. So 4. So for all those y values, right, there's a graph. And 4 is the highest. Once you get to y is 4, then there's no more graph. Okay? So the range is -2 to 4.
Professor, how do we know when to use brackets and not parentheses?
So the parentheses are used mostly if you go to infinity. Okay, so like if this graph right here had arrows to it and you pointed to infinity, then you'd be using things like, oh, the domain is -infinity to +infinity. Those are round. But otherwise you use brackets, or we'll see later when we have like exponential graphs where you have something like this. It kind of keeps going but never quite touches the 0, then you use round. But if it's sort of, if there's a point there, then you use the bracket because you have a point on the graph that was generated using that x value or that y value. Okay, good. So the domain and range, you look at what x values are used, and range is what y values are possible. Okay. All right, let's look at number 7. Okay, so number 7 seems a bit, oh, it's still a formula. It kind of doesn't have anything to do with domain or range. Okay, number 7 says the length of a pendulum in inches L is a function of its period, or the length of time it takes to swing back and forth in seconds. We're going to do an experiment with the pendulum next week, I think. The function is defined by this formula. Okay, so this is the formula of the function that shows how length depends on the period of the pendulum. So L is the length. The other way, TH. And T is the period. Okay, so the period is if you swing a pendulum, how long it takes to go one full swing to get back at the beginning. So it's like if my pendulum is like this and it swings, the period is the time it takes to get back to its initial position. Okay. So find the length if its period is 4 seconds. Okay, so what is it asking me to do in A? Find the length. If the period is 4 seconds, where am I plugging that in?
In T?
In T, yeah.
So would it be 4 squared?
Yes.
Yes, it would be 4 squared. So because it's T squared, you do 4 squared first, which is 16, and then you multiply it by the 9.73. Okay, whatever that number is. I'm too lazy to use my calculator. It's right there next to me, but it's just like, I'm gonna let you guys do that. All right. Part B says
155.68.
155.68.
Yes.
And in inches. Inches. Okay, there we go. All right. B says the focal pendulum in the Pantheon in Paris has a 62-pound iron ball suspended on a 220-foot wire. What is its period? Okay, so again, we're using the same formula. Okay, so what am I plugging in for here?
So 220 is the length.
220 is the length.
And
it's
then
asking me for
62 is the period.
No, 62 is how heavy it is. The period is given in seconds, right? And I need to find the period. So basically, I need to find
okay.
T. So that 62 is irrelevant. Actually, for a pendulum, the weight of whatever is attached to it doesn't really matter very much. It matters a little bit because of friction and stuff like that, but if there was a vacuum and there was like no air, something that was light would move at the same speed as something that was heavy. It's kind of peculiar to pendulums that actually happens. All right, but I need to solve for t. So how do I solve for t here?
Divide 9.73.
Divide that first. And I get t squared equals whatever that number is. I'm going to use my calculator now.
It is 22.61.
22.61. How do I find t?
Square root?
Square root, yeah. So take the square root.
I might have failed the test, but I'm doing well.
Really doesn't make sense.
Seconds.
Doesn't make sense, Michael.
Don't laugh, don't laugh.
That's why there's retakes.
It's 23.48.
You get 23.48? Okay, so 220 divided by 9.73. 22.6.
I did 3.7. Never mind, ignore me.
Okay. And that's a 4.75. All right, questions on that one? Okay, so you can see a lot of these problems are like plugging in. You're given a function of sort of how these things are related, plug in to find whatever. Okay, all right, 8 is the last problem. Okay, so consider this function. So find f at 5, f at n, f at x plus 2. Okay, so anything that's in parentheses with the function gets plugged in for x. Okay, so f at 5 is going to be 3 times 5 plus 1 squared minus 4. Okay, and then we do the math. So the parentheses first, we get 6. Then we square the 6 to get 36. Then multiply by 3, 108, and then subtract the 4. Okay? All right, then for B and C, you're sort of, again, you're plugging whatever's in parentheses for x. So for B, for example, f at n, the x gets replaced by n. And there's nothing really to simplify, so that's it. All right, and for C, the x gets replaced by x plus 2. So we get 3, and x gets replaced by x plus 2, and then plus 1. And we get 3, and we can simplify here, x plus 3 squared minus 4. Okay, and then that's it. Like, we really don't simplify anymore. Okay. So in part D, it says use your calculator to graph y equals f of x and y equals f of x plus 2 on the same axes, right? So this is a good opportunity for me to show you a graphing program called Desmos. Okay, we're not going to use graphing calculators in this class because most of you don't have them. I think I have them just because I'm a math teacher, but they're a bit outdated. But Desmos is great, and we're going to use Desmos a lot in the upcoming sections because we're going to see how graphs change depending on what you do to them. We're going to look at graph translations and reflection and shrinking and stretching. So that's sort of part of the upcoming lessons, okay? So I'm going to go to a program called Desmos. Okay, so write it down. Desmos. Okay. So this Desmos program, you just Google it. I'm gonna go to Desmos. And start graphing. It works well on an iPad or a phone too. And then in here, you type in the function that you want to graph, right? So let's look back at the function that is said. Okay, I think it might do copy and paste.
یه رو دیگه تحمل کن تموم میشه.
It doesn't copy and paste very well. All right, so I typed in f of x equals 3 parentheses x plus 1 squared minus 4. Okay, so we type that into the box. Okay, so just to show you, I do f of x equals 3 parentheses x plus 1. Square is is the caret thing above the 6. So if you hold shift and 6, it gives you a power. And then use your arrows to get out of the power to do the minus 4. Okay? So that's kind of how you type a function in, right? So the problem says that you want to graph y equals f of x. So I type in the formula and then also graph y equals f of x plus 2. So in the next line, I'm going to just say f of x plus 2. Okay? So the graph basically takes the original graph and plugs in x equals x plus 2. So you can do it by hand. You can type in the function again and replace x with x plus 2. Like if I do, say, another function, it's 3x plus 2 plus 1 squared minus 4. Okay, you can see that you get that function. Or you can just type in f of x plus 2 and it does the same thing. The program plugs it in itself. All right, so here's the graph of the function and the graph of the function where you place x with x plus 2. So what you notice about them is they're the same shape. They're both parabolas, but like the purple one moved a couple of units in the negative direction. All right. So as I said, we're going to use this program a bit. We're going to make graphs with it, and you can like copy and paste the graphs into your document. So if I go to this arrow right here and I export the image, then I can grab the picture. Okay, you can either download the image, or is there a copy?
Oh, but you have to use an app called Snipping Tool.
The what?
It's called Snipping Tool. I use that
Oh yeah, you
sometimes.
can use snipping tool. You can capture part of your screen.
Because
This embed feature right here, it gives you a, I think that, let's see, if I copy that, does that put it, let's see. No, it doesn't.
But because
It would embed it in a website.
oh, you know what? How I did? Because if instead of just using drawing on Google Docs, I use Snipping Tool, but I was just checking the answer.
Yeah, I think I did. So this is what I'm doing. I go to here and to export image, and I right click on the graph and I copy the image. And then I'm going to do Control V, and I'm going to paste the image like this.
To make it small.
And that you can copy and paste it into your document. Okay, so you can see the graph like that. All right. So I want you guys to try that. Okay, so that for A to D right there. Go to Desmos and type in the function, and then type in the f of x plus 2 like I did, and then copy and paste it to your Google Doc. So that's good practice for doing a lot of the stuff that we're going to do this week is going to be with graphing and with changing functions around to see what they do. Okay. Nice. I'm gonna erase it from here because this is for, I don't want to do the work for you. Sorry, group 7. All right, so again, take a few minutes to do the Desmos thing, and then we'll wrap up. Okay. I think this is all we're gonna do today. I'm not gonna start anything new. Oh yeah, if you're typing things and mathy things sometimes are difficult to type, there's a good way to insert nice equations. If you go to insert and you go to equation, then it gives you like this bar right here that has like equation tools. So like if you're trying to type in I noticed that somebody said SQRT, square root. If you go here, math operations, then it has like fractions and it has square roots and it has a bunch of other stuff. So if I want to type like a square root of x minus 3, then it makes it nicer, okay? Or if you want to type powers, okay, you can sort of insert. I don't know what happened now.
May change the font.
All right, so an insert an equation, and then I can do powers. So I can do x to the power. No, that's not working. Powers are a bit easier. You just do x and then shift 6, and it does a power like that. Okay. But yeah, the insert equation thing, if you're typing equations and you don't like what they look like, then you can use the insert equation, and it does a nice job of typing things up. All right, so which group? So group 2, my graph doesn't look like this. Okay, make sure that you
didn't, it says to put into your calculator y equals f of x and y equals f of x plus 2.
Yeah.
You put in an equation that was different.
You know, this is what you're supposed, this is the equation that you need to put in, because f of x is this.
Then why does it say in D to put in those two?
Yeah, so it means put in this function to graph. So you need to type in this function into Desmos. So like this. So you need to type in the identical function.
Oh, okay, that makes sense.
Oops. Ooh, nice looking graph, group 4. I'm not going to call you by name anymore. I'll just call you by group. You are not now a unit. Let's see, group 7. Yeah, so to copy and paste it, after you make the graph, click on this arrow that says share graph and export the image. Okay, you can sort of download the image, but what I did is I right-clicked on it and I copied the image, and then you go back to your document and then you paste the image and it should show the graph. If you paste the link, it doesn't show the graph. Paste the image. Oops. Oh. Don't do that. That's a good for.
آره.
Oh, I think I've already looked at this one. Oh yeah, I've already looked at that one. Group 4, group. Let's see the group 1.
چه باحال. یه روش یاد
Nice, nice. All right. Okay, so let's see. All right, so before class ends, okay, so today we did functions 2, which is basically function notation, seeing what is a function and what is not, and evaluating, lots of evaluating functions and sort of writing functions for the kind of application problems. So I'm not going to start functions 3. I'll do that tomorrow.
Wait, is the function one's classwork sorry, is this to turn in?
So when you're doing classwork, it is to turn in, but you don't need to do anything to submit it because I have access to all the Google Docs, so I can see the stuff.
I'm still looking for that. How to turn that in. I was just looking for that.
Yeah, there's nothing to turn in for the classwork. Anything that you're doing during the class time in Google Docs, I can check. So there's no submission that you need to do, all right? Today, you should have finished function 1 classwork. If you haven't, you can still work on it. So the stuff that we started yesterday or we're doing yesterday in class, that should be completed by maybe midnight tonight.
Yeah.
Functions 1 homework, you need to complete it and submit it in Canvas by midnight.
I just did that already.
Perfect. Okay.
But I did functions 2, but there's a homework version, but I was still doing it.
All right. And so for tonight, if you haven't finished the classwork for functions 2, you should do that.
But another friend of mine helped me. She helped me.
Okay.
So is functions 2 homework also due tonight?
Yes. So that's for tomorrow. So do tomorrow. So do tomorrow is finish.
I don't know what class for today.
Finish the functions 2 classwork and do functions 2 homework.
Can we have that like as the memo on our Canvas or something like that?
Do you have functions 2 homework in Canvas?
No, like the announcement of what is due.
I think it's in the announcements. I'm not sure. I might have to adjust it because I think I'm probably a little behind, but that's okay. Maybe you should have I don't know. I'm trying to organize it to let you guys know what's due clearly, but I seem to be having a bit of problem with that. All right, so yeah, I think that I need to adjust this because we haven't done functions 3. Let's see, so Monday functions 1, class or homework due on Tuesday. Tuesday we did functions 2, so class or and homework are due on Wednesday. And we're probably going to work on let's do that. Okay. All right.
So we have a quiz tomorrow from
Well,
function.
yeah, let's have a quiz tomorrow on these first 2 sections. Okay, so I think tomorrow is a good time for a quiz.
Function 1 and 2.
So yeah, quiz tomorrow.
How many questions? 5?
Yeah, the typical on functions 1 and 2. Okay, so for tomorrow, work on finishing the classwork if you haven't, and doing the homework for functions 2. All right, and there's going to be a quiz tomorrow on those first 2 sections. Okay, and have a look at, if you want to make up test 2, you have a week to do that. It's going to be due April 14th. So kind of think of if you want to make it up or not. Let me know if you're having trouble finding the graded test in Canvas, and I can help you with that. And you'll need to do corrections and submit them, and you can take the test, makeup test. All right, that's it for today's lesson.
Thank you.
If
Bye. Thank you.
If you have questions, hang around, let me know.
Thank you. Have a good day.
You too, bye.
Bye.
Hello?
Hi.
Hey. No, I was just wondering, on number 4, I got confused. Well, when it comes to like setting up the word problems, like setting up the functions, I don't know how to do them. Like, is there like a basic formula for all of them? For all functions, like G, DT, F?
No, it depends on the situation.
Yeah, because I don't know which goes where. That's the thing. It's like, okay, number 4 is like the foundation to know everything, to know how to do the ones behind.
Well,
under it,
number
right?
4 is a linear function. Okay, so
But you're still plugging it. Yeah, you're still
yeah,
plugging
we
it in.
looked at these a few units ago, a few chapters ago.
Mm.
So I don't know if you remember when we were doing kind of problems, and also we did an activity of what people earn on jobs. Like we did an activity called the best job. We're looking, oh, this person.
Yeah, we did that.
Yeah, so this is the same type of thing. So basically, this is set up because he's trying to figure out how much he gets paid, but he's getting paid a certain amount a day that's fixed. Right?
Sure.
So the fixed amount was when it's like,
All right.
$5.25 an hour, and for 8 hours, that gives you the $42. That's kind of the pay that it's getting per day if he's working 8 hours a day. And this other one, the commission, because you have the 3%, then that has to multiply X, that has to multiply how much he's selling, right? So then when you put them together, you have the $42, and then the money that comes from the commission, and that's going to give you the total amount for how much he's making each day. Okay.
So you're saying, so am I still using this formula, but trying to plug it into the function with the function in front of it, right?
Yeah.
Like
so instead of writing,
yeah.
Instead of writing an equation that's like y equals mx plus b that we're used to, then we're writing it in the function notation, but it's the same kind of formula. It's just that instead of using the letter by itself, we have this parentheses x that kind of tells you, oh, what he's making is a function of how much he's selling.
I see. So yeah, that was the formula. Okay, so we're just supposed to plug it into this formula. This is the basic formula.
Yeah, exactly. So yeah, we're graduating from just saying y equals mx plus b to f of x equals mx plus b, because that gives, like, explicitly tells you that how much he's making is a function of how much he's selling. So it's a more detailed description of the equation.
Huh. Okay. Yeah, but it's still kind of confusing in a way. It's like, okay, now we have dollars. All right, so if we're using this ymx plus b, then are we still using the other formula? You said we were still using the other formula from a couple weeks ago, which is the interest equals.
Right, this is the formula that we're using a few weeks ago. So
this was? Wait, that's the same. Could you write it down? The other form, because the other formula looked like, remember we were trying to measure interest. We were doing interest rates, right?
Mm-hmm.
Yeah. So.
So yeah, the interest rate formula, that's a different one.
Oh, okay. So yeah, because I don't remember on the other week.
Yeah. So this y equals mx plus b was probably about a month ago when we were
Oh,
looking at slope and
yeah.
y-intercept, and the slope represents the kind of rate, the periodic rate of change,
Mm-hmm.
and the y-intercept is like the flat rate. So this is from about a month ago. So yeah, look for, if you have notes or the book, or look for like,
I remember the YMX plus B.
yeah. So it's like linear
just-
relationship or systems of equations. So we've done a bunch of problems like this in that unit.
So the first step is to plug it into this formula. Then how am I supposed to know which goes which again? You mind explain that again? Sorry.
The B part, the one that is not next to the X, is
Yeah.
a flat rate. This is basically, in this scenario, is like how much is he getting paid even without selling anything? So the B is like when X is 0, you get this B value. So when he's not selling anything, he's still making $42 a day, okay?
Okay.
And then the slope is like this per. Okay, so he's like 3% commission. He gets 3% per each dollar that he's selling. So the slope is kind of this.
So the
this
slope.
rate. Mhm.
Slope means commission, right?
Yeah,
Commission.
slope means commission.
And then you have the B equals the flat rate.
Yeah.
The flat rate, and you made the flat rate. So the flat rate can only be found after we multiply X and M, right?
In this particular situation, sometimes some problems gives you, oh, he makes $100 a day, right? But in this situation, it said it's $5.25 an hour, and he works 8 hours a day, so we had to multiply him to figure out the flat rate. So, and some problems it gives it to you, and some problems you need to multiply, like in this case.
Will all problems look different? Well, I mean, I'm plugging it. Well, when it comes to like plugging this in, will most of them look different from like money, from the money analogy of this?
They will, yeah. They'll look different in terms of kind of, there's different applications, but they'll fit the same pattern because you have these two separate sources of money. One that comes from, you get paid this no matter what, and that's the B. And then there's this other source of money that you're making because of how many things you're selling or the commission that you're getting, and that's the MX part. That's the slope part. It's kind of like a type of problem that fits into the y equals mx plus b, but each problem is different because of kind of the information that you give it is slightly different.
Yeah, that's why I want more like like a universal meaning, like M instead of like B equal flat rate, because it's not always going to be the same application, right? So what is?
But B will always be a flat rate, no matter what the application is. And M is always the variable rate, no matter what the application is.
M is the variable rate.
It's just that when you read the application, what you need to kind of learn to do is recognize that it's telling you, oh, this number means the flat rate, this number means the variable rate. So that's kind of the work that's involved, is recognizing what the flat rate is and what the variable rate is.
And what's X always going to mean?
Well, X and Y are the variables, right? So X and Y is like, what am I interested in? So it's like, oh, he's interested in how much he's getting paid per day. So that's one variable.
What do you mean by
that depends on how much he's selling, and that's the other variable.
So total pay or total?
Yeah, so what Y or M in this case is the total pay. And X is like how X represents, and it tells you in the problem, it tells you X and Y. So X represents the total dollar value that Miguel sells. And M, it's like which function represents how much Miguel earns in a day. So that's M represents his daily earnings, right? So it tells you in the problem what the variable means.
Okay. All right. Thank you.
Sure, you're welcome. You'll have a good day.
You too. What time does your next class start?
3:30.
3:30. Are
Yeah.
you gonna still be? Oh, I was just gonna. I don't wanna like take any time from anybody else. That's why. Just in case I had another question, I was just
You
gonna.
can stick around. I'll leave it open. I might step away just to
Okay.
get some water or take a break before my next class, but I'll be back in a couple of minutes.
Sure. Okay.